algebra literally right at the top here, and I've been saying this to you guys all along. It's just the number of zeros, roots, answers, whatever you want to call them, of a polynomial is equal to the degree of the polynomial. And the degree, remember, it's just the highest power of x that you have in your actual polynomial equation. So we've been talking about that all along here, but I didn't call it the fundamental theorem. So the number of zeros or roots is going to match the degree of the polynomial highest power of x. Okay, now just two little things for different types. We did on our last lesson the imaginary root theorem. So imaginary roots always have to come in pairs. And if you guys remember, we would have like a plus bi and a minus bi, because if one is a root, automatically its conjugate is also a root. So imaginary roots always have to come in pairs, so they can only come in even number sets. Now, a real root doesn't necessarily have a pair or a partner. So real roots are something that you can actually see on the graph. So it says real roots are visible on the graph of the polynomial. I'm going to say on the graph. And all you would be looking for to see a real root on a graph is any x-intercepts. So where it touches or crosses the x-axis. So you can see those on the graph. Those don't necessarily, or it doesn't come in pairs. It could just be a single root. It could be 3, it could be 5. They don't have to come in pairs. Imaginary roots, though, do have to come in pairs. So what I'm going to have us do, we're just going to write all the possible combinations of roots based on just the leading term in a polynomial. So I'm not going to give you a graph. I'm not going to give you the entire polynomial equation. I'm just going to give you the leading term. And based on that, you should be able to tell me like how many answers it would have, how many roots, zeros, whatever you want to call them. And then we're going to write how those could shake out, like what possible combinations we could have. All right, so here's my first little, and I'll just make a little table for our answers because there's more than one answer. So how many answers, roots, zeros, whatever you want to call it, would you have if you know that the very first term in your polynomial in standard form is 5x to the 6? Like how many answers would it have to have? What do you think? 6. Okay. Now, here's how I would recommend writing the possible combinations. I always start with imaginary because I know the imaginary ones have to come in pairs. So it's got to be even numbers. All right, so let's say I did not have any I don't have a graph, I don't even have the whole polynomial. So I'm just writing possible combinations here. Let's say I had no imaginary solutions. How many real solutions would I have to have then? 6. It would have to add up to 6, right? Because I know I have to have 6 total. So that's one possibility. All right, now, again, I go with imaginary. They have to come in sets of 2, so I'm only going to use even numbers. So I could have 2 imaginary. If I had 2 imaginary, how many real would I have to have for this example? What do you think? Oh, he's holding it up with his hands. It has to be 4. They have to add up to 6. Okay, now, I could have 4 imaginary. If I had 4 imaginary, how many real would we have to have? 2. It has to add up to 6 every time. All right, and then we could have 6 imaginary roots. If all 6 are imaginary, then we would not have any real. And I wouldn't go beyond that because the next imaginary possibility I could have would be 8, and 8 would be more than the total I should have for a 6-degree polynomial. So those are all the possible ways you could have zeros if we actually had a graph or more information here. Okay, now the one in the middle says the leading term is negative 2x to the 5th. So how many total answers would a polynomial that starts with negative 2x to the 5th have? How many total? 2 negative 2x to the 5th. How many answers would you have? 5. Okay, I was about to have a heart attack. All right, now again, I'm just going to do imaginary first because they have to come in pairs. So I could have absolutely no imaginary roots. If I don't have any imaginary, how many real roots would we have to have? All 5 of them, right? Okay. Now, the imaginary have to come in pairs, so it can only be even numbers. So I could do 2. If I had 2 imaginary, how many real would we have to have? 3, because it has to add up. Each one of these rows would have to add up to the total number you need, which is 5 for this example. Okay, so then I could have 4. In that scenario, then to add up to 5, I'd have to have just one real root that we could see. And then the next even number I would have would be 6, right? 6 is too big if I can only have 5 total. So those are there. I only have 3 possible combinations of how my answers could shake out if I have a 5th degree. All right, and then the last one, this is 9x to the 7th. All right, so just the highest power of x, that's how many zeros you have, so 7 for this one. So again, I do the imaginary just in sets of 2, so I'm just going to say 0 imaginary. If I don't have any imaginary, then I'd have to have 7 real to add up to 7. Imaginary have to come in sets of 2, so I'm just going to use even number here. So next even number would be 2. If that's the case, then I would have to have 5 real. And then I'm just going to use the next even number, which would be 4. And then we'd have to have 3 real. And then maybe I'm writing a little bit too big. The next even number is 6. And then I would have 1 real. And the next even number would be 8, and that would be too many. So those are all the possible combinations if I have a 7th degree. Is anybody having a question? Okay, now, these on the bottom here are a little bit different. I'm going to give, there's no equation written here, and you don't have to tell me specific numbers or anything, but I'm going to give you the degree of the polynomial, which will tell us how many roots that we should have, and then from the graph, we're going to determine how many are real, and then how many would have to be imaginary, because you cannot see the imaginary ones on the graph. Okay, so if my first picture here, this says this is degree 7, how many real zeros can you see on that graph? You look at that graph, how many real zeros do I have? 3, for sure. Like, and it doesn't matter what the number is. I'm not asking you that because they're not in nice places here. So 1, 2, 3. So this would be 3 real. If that graph has 3 real, how many imaginary would it have to have? If it's a 7th degree, it has to have 4 imaginary. Okay, good. And I'm just going to kind of abbreviate that a little bit. So that has 3 real that I can see to add up to 7. That means this graph would have 4 imaginary solutions. We just can't see them on the graph. Okay, now this guy in the middle, it says it's 4th degree. So it'd be quartic. How many zeros can you see on that graph? All 4 of them. Yep. Okay, so they're really close together here, but there are 4 real. How many imaginary do I have then? It's 0. Like if all 4 of them are on the graph, so this would be 0 imaginary in that scenario. What am I hearing? Are they drilling or something? Do you guys hear that? Okay, it's not me. I don't know what that is. Okay, 5th degree. All right, how many real zeros do you see on this graph? Just 1, right? If this is the only place it touches or crosses the x-axis, and then the rest of the graph interacts. Okay, so this has 1 real. So how many imaginary do I have to have? 4. If it's a degree 5, this has to add up to 5. And you'll notice all of these that I've written down for the imaginary, they have to be even numbers. If they're not even numbers, then we maybe made a little bit of a mistake. All right, I got 2 more and then we're done. Okay, this one is a 3rd degree, so this would be cubic. How many real zeros can you see on that graph? All 3 of them, right? 1, 2, doesn't matter what the number is. This is 3 real, so I have all the answers right there on the graph. This one would have 0 imaginary solutions because I take care of all 3 on the graph. And then I got one last one. This is a 6th degree polynomial. And you see it kind of looks like a parabola a little bit, but the bottom of it's almost more flat. How many real zeros does that last graph have? None. It doesn't touch the x-axis. So this has 0 real, so that means all 6 would have to be imaginary. So we're just writing down the possible options.